So today you're learning how to simplify cube roots. Yesterday you learned about square roots. And so the reason you could tell that those are square roots is because you didn't have a number right beside the square root, although it was like a 2 that was assumed, but we're doing the cube roots today. But you'll still start off by doing the same thing here. So you'll write out the prime factorization of your number under the radical symbol there. So I'm just going to make a list of primes that we can have it to help you. So remember, these are primes because the only numbers that divide evenly into them are 1 in itself. So your first one will be 2, and then 3, 5, 7, and 9 wouldn't be 1. Your next one will be 11. And it'll continue on. I just won't write the rest there. So for this first one here, so you're going to write out the prime factorization of the 144. So remember, for the ones that are even, I would divide by 2 until you can't anymore. So for this one, the 144 is even. So I would divide by 2 first. And if you do, you get 72, which you can take another 2 out of, which would then get you down to 36. And then 36 is still even, so you can take another 2 out of your 36, which would then be 18. And then you can take another 2 out of your 18, which would then put you down at 9. And then for 9, so you couldn't take another 2 out because it's not even, but the prime that does divide evenly into 9 would be 3. So if you divide by 3, then you'll get 3. Because it's also prime. So you can list that there. And then, so this is your list of primes. It will multiply to give you 144. Remember, you can always multiply these together to make sure you didn't miss anything, which is a good idea the more numbers you have under the radical symbol here. And then this one's just different from yesterday because you are taking these out in groups of 3 instead is the only difference. So you have a pair of 2, or a group of 3 2s here, so you can take these 2s out. So you'll cross these 2s out and bring one of them outside. And then you can just rewrite your answer the best way. So you'll have 2 on the outside of your cube root symbol. And then remember, inside, you'll multiply these 3 terms together. So you can multiply the 2 by the 3 and 3. So then you'll have 18 inside that. So then your simplified cube root will be 2, cube root of 18 for that one then. And the reason you could do that is because 2 times 2 times 2 would be 8, and the cube root of 8 would be 2. So that's why you pretty much are doing the cube root of these 3 numbers and then leaving whatever is left inside there. And I'm going to skip around on this note sheet here, but I am going to do number 1 next here. So you're writing out the prime factorization, and so if it's even, I would divide by 2 until you can't anymore. So this is even, the 24. So I'd divide your 24 by 2 first, which if you do, then you're down to 12, which you can take another 2 out of the 12, which would then be 6. And then when you're at 6, you can take another 2 out of the 6, which would then be 3, which is also prime, so you can list that there. And then remember, now that you have your list of prime factors, so you're taking them out in groups of 3. So this group of 3 2s can come out here. So this will be 2. So this will be 2 cube root of 3 for your answer for this one then. So that'd be your simplified radical. And then for number 2, so you're going to write out the prime factorization to start there also. So the 128, so that's even. So I would divide by 2 until you can't anymore on this one. So if you divide the 128 by 2, then you're down to 64, which you can take another 2 out of your 64, which would then take you to 32. So 32 is still even, so you can take another 2 out of your 32, which would then be 16. And so 16, you could take another 2 out, which would then be 8. And then 8's still even, so you can take another 2 out, which would then give you 4. And then once you're at 4, you can divide by another 2. So if you divide by 2, then you will get 2, which is still prime. So pretty much you'll have 7 2's here. And you can always double check and multiply this 2 together 7 times. You will get the 128. And so remember, for every group of 3, you'll bring one of them out. So you're going to actually bring 2 of them out here. So for this group of 2s, you can bring 1 outside here, and then you'll be able to bring another set of 2s out here because of this one. So then you can multiply these 3 outside. So 2 times 2 times 6, that'd be 24 outside. And then you'll have the cube root of 2 is the only thing you have left inside then. And then for number 3 here, so this is the cube root of the negative 135. I would ignore the negative just to start. We're going to list out the numbers and then I'll talk about the negative sign. So just pretend it's a positive to start to make it easier here. So you're going to write the prime factorization of the 135 here. So the 135, so it's not even. So you shouldn't divide by 2 first because you know 2 won't go into it. So you can see if it's divisible by 3. So if you do 135 divided by 3, then you'll get 45. So I would put one of your 3s here to start because 3 will divide evenly into that. And so once you, like I said, once you divide the 135 by 3, you get 45. So I would divide the 45 by 3 to see if you can take another 3 out of the 45. Which if you do divide the 45 by 3, it goes in evenly again, and then you're down to 15. And then you can take another 3 out of your 15. And if you do divide it by 3, then you'll have 5, which you can also list here because it's prime. So 3 times 3 times 3 times 5 to start. And then we'll take care of the negative here. So I'm going to make the set of 3s negative because you're going to need 3 negatives to multiply together that will give you, because if you have like 2 negatives, they wouldn't multiply to be a negative there. So I'm just making one group negative here. So it'll be these 3s. Because the negative times a negative times a negative would be a negative there. Or you could put it with a 5, but then your negative would still be left in there. I was just going to bring it out so you have less things under your square or the radical symbol. And then so every group of 3 you can bring outside. So this group of 3s, you get negative 3s you can take out. So this would be negative 3 and your 5's left in. So negative 3 and so you'll have negative 3 and then the cube root of 5 then. Okay, I'm skipping number 4. We're going to do number 5 next here. So this is 168. So it's even. So I would divide by 2 until you can't anymore here. So if you divide the 168 by 2, then you're down to 84, which you can take another 2 out of the 84, which would then be 42. And then 42 still even, so you can take another 2 out of the 42. And then if you do, you'll get 21. And so 2 doesn't divide even into the 21, but you can see if 3 would go into your 21, which it will there. And so 21 divided by 3 would be 7. So then you have times 3 times 7, because you can list both of them because they're both prime there. And then for the variables here, so for this, if you're doing a square root, then you'd have to make sure exponents divisible by 2. For the cube roots, these are different because you need to make sure the exponents are divisible by 3. So this b to the 3rd is fine. And then this c to the 11th, you can't divide 11 by 3, so you're going to need to rewrite it as the next smaller power. So this one here, have to rewrite the next smaller power from 11 you can't divide by 3 would be 9. So this would be b to the 9th and then b squared, because that'd be b to the 11th together. And then you can take out what you can after this. So remember, every group of 3 you can take out here. So these 2's can come out. And then for the variables, so you want to divide the exponents by 3, because one's yesterday, you divide by 2, but we're doing the cubing now. So this will just be a b outside with a 2, because you can divide the 3 by the 3. And then you'll divide this exponent by 3. So 9 divided by 3, so that'd be 3 then. Hold on, that was just a C. And then, so you have 2bc squared, or cubed outside then. And then you have the cube root of, and then remember you can multiply those inside. So you have 21b squared left inside. And then I'm going to do number 6 here. I'll do a different color so you can see. So for 6, so this number is not even. So I would see if 3, or if the 1029 is divisible by 3. So you can divide this by 3, which would then give you 743. And then for the 743, you can try and divide it by 3, but 3 won't go into it evenly. And then your next prime is 5, and 5 wouldn't go into the 343. And then the next prime after 5 would be 7. So you can divide the 343 by 7, and it does divide evenly. So then if you divide it by 7, then you get 49. And then you can take another 7 out of the 49 then, and then you would be left with 7. So you'll have 3 7s then, and then 1 3. And then remember, you can rewrite the exponents because you want to be able to divide your exponent by 3. This one you can't right now. So you're writing as the next smaller power that you can't divide by 3. So this will have to be d to the 6th and then another d. And then you can bring out this group of 3 7s then. And then you'll divide the exponent by 3 for the variable. So you'll have d squared then. And then your other stuff will have to stay. Hold on. So this is d to the 6 and then a d. And then we brought this out, these 3 7s, and then this is d squared. Okay. So then you'll have 7d squared outside, and then the cube root of 3d would be left in there. Okay. For number 7, this is the cube root of the negative 8 here. So like the other negative I was talking about, so I just pretend it's positive to start, and then we'll figure out where the negative can go. So you're writing out the prime factorization of 8, so that's even. So you know you can divide it by 2 first. And so if you do divide by 2, then you get 4, but you can take another 2 out of the 4. And then if you take out the 2 from the 4, then you're left with the 2, which is also prime. So you'll have 3 2's there, because 2 times 2 times 2 will give you the 8. And then to take care of the negatives here, so you'll pretty much need to make all 3 of these negative, because if you multiply the negative by itself 3 times, you will get a negative in the end. And then you want to make sure that you can divide the exponents by 3, and if not, you can rewrite them. So x to the 4th, you can't divide by 3, so you can rewrite it as the next smaller power. So that'll have to be x to the 3rd, and then another x beside it. And then you can divide the exponent by 3 on the y, so you'll have to do the same thing. So the next smaller number from 5 you could divide by 3 would be 3. So you'll have y to the 3rd, and then y squared, because that'd be y to the 5th. And then you can bring out this group of 3 negative 2's. And then for the variables, remember you'll want to divide the exponents by 3. So that when this x comes out, you'll have an x with it. And then the same thing with the y. So you'll have a y because you want to divide the exponent by 3. So then you have negative 2xy here. And then the cube root of what was left? XY squared. Okay, I'm gonna, just so you know, if you were doing number 8, this E, it would have to stay in there because you'd have enough E's to come out. But I'm not gonna do that one because you have like lots of factors you'd have to run. I'm gonna do number 10 next here. So for number 10, you have negative 500. So it's even. So I'll divide by 2 until you can't anymore here. And I'm going to ignore the negative to start. So if you divide the 500 by 2, then you have 250, which you can take another 2 out because 250 would still be even. So if you divide the 250 by 2, then you're down to 125, which it's not even, so you can't take another 2 out of 125. And then you can try and divide it by 3, but 3 won't go into it evenly. And then, so the next time that will go into the 125, then will be 5. So if you divide the 125 by 5, I was going to move this over so you have more room. So if you divide the 125 by 5, then you get 25. And then you can take another 5 out of the 25 then. So if you divide the 25 by 5, then you'll get 5. So you'll have 3 5s and then 2 2s here. And then we're going to take care of the negative here. So you're not making the 2's negative because the negative times the negative wouldn't be a negative there. So you'll have to make this group of 5's negative because negative times negative times negative would have given you a negative there. And then for every group of 3, you can bring one of them out. So these negative 5's will come out then. So you can multiply this. So it'd be 20, and then your cube root of 4 then. Okay, and then for number 12 here, so you have 224, well, negative 224. So this is even. And so like the others, you can pretend like it's positive for now, and then we'll figure out where the negatives can go. So I would divide by 2 until you can't anymore at the 224. So if you divide the 224 by 2, then you get 112, which it's still even, so you need to take another 2 out of the 112. And then if you divide the 112 by 2, then you'll get 56. So 56 is still even, so you can take a 2 out of 56, which would then be 28. And so 28 divided by 2 would then be 14. Then you can take another 2 out of your 14. So then you're down to 7. So there should be 6 2's and then a 7. And you can always multiply them together to make sure you get the 224, that you didn't miss anything. Hold on, apparently I think I have an extra 2. Really, you should only have 5 of them here. Because, okay, 225 divided by 2 would be 112, divided by another 2 would be 56, divided by another 2 would be 28, and then 28 divided by 2 would be 14. Yeah, and then 2 times 7 would be 14. Okay, yeah, that's right, sorry. That's why it's a good thing to multiply them together to make sure you didn't miss them there. Okay. And then remember for the variables, you want to be able to divide the x in it by 3 here. So you can rewrite this. So it'll be p to the 3rd and then another p squared. And then to take care of the negatives here, so you're going to need 3 negatives inside because the negative times a negative times a negative will give you a negative there that you wanted. And then you wouldn't need any more inside because it's already taken care of. And then so this group of negative 2's you could take out. And then you can divide the exponents by 3, so that would be p once it comes out then. So you have negative 10 p, and then inside your cube root symbol. So you multiply these, what you have left. So 4 times 7, so 28 p squared to be left then. So I'm posting a Google Doc to work on today. So it's a mix of, most of them are cube root symbols that you're doing, but some of them are square root symbols like yesterday. So just make sure you pay close attention as to what it is. That way you know whether you're breaking them out in groups of 2 or 3. So you can work through that. Although if you want to take a picture and send me your answer, that way, because you can't type these symbols in the Google Doc, so you can send me a picture of what you've done if you would rather. But let me know if you need help on these though, because I know they're kind of confusing.